Hello everyone, my name is Matthew Lake here. I'm a PhD student at the University of Waterloo in Canada. Today I'm going to present a work that I did with my colleagues Dimcho Karakeshev, Ethan Wang, and Ian Goldberg called Augmented Pin Entry Techniques for Smartphones Using Pre-Touch Information. People often store personal information on their smartphones and protect this information behind pin entry or other authentication techniques. However, these authentication techniques have pitfalls. For example, if somebody's looking over your shoulder, they might be able to see your PIN as you're entering it. Today, I'm going to talk about some attacks on authentication techniques and authentication techniques themselves. I'll introduce our 3D pattern authentication technique, talk about its implementation with motion capture, and the pilot experiment that we conducted measuring the shoulder surfing resistance and performance of our technique. I'll start off by talking about some attacks and authentication techniques. In our work, we focus on two attacks in particular. The first is shoulder surfing. Shoulder surfing is when somebody looks over your shoulder and can see what you're doing on your phone screen. This is an easy to execute attack, and even if you're tilting the device away, the attacker can still guess what the pin is 45% of the time. The second type of attack we look at is the smudge attack. This is left by oily residues from your finger on the screen. If you were authenticating using a pin or pattern, the smudges left behind might give attackers some insight into what your pin or pattern was. In terms of common authentication techniques, there's a few different kinds. There's the pin keypad, or similarly the password input, the pattern lock, which is found on Android smartphones, and biometric authentication, for example fingerprint or face recognition. We focus on manual authentication techniques in our work, like pin and pattern, rather than biometric techniques. Although biometric techniques are common, pin and pattern are still required in certain circumstances, like when you're authorizing payments or when you're rebooting your phone. There's a wide range of authentication techniques in the literature. In terms of pin, password, and pattern type locks, Swipe-In by von Zeschwitz and colleagues took the conventional keypad entry and replaced each number with gestures. So depending on where you started from on the screen and the direction you swiped in, it would input the corresponding number as part of the PIN. There are also tactile locks, for example the phone lock by Bianchi and colleagues. In this work, each PIN digit was mapped to a different vibrotactile pattern, and so to enter the PIN you had to remember which vibrotactile pattern corresponded to which number. There are also graphical locks, for example Awasei by Takeda and Koike. In this lock, a user would first choose an image from their smartphone, which would be broken up into small pieces. When authenticating, these pieces would be mixed in with other pieces of other images. To authenticate, the user had to correctly specify which image part came from the initial image they selected multiple times. There are also several small-scale locks, for example Tiny Lock by Quan and Na. In this lock, they took the conventional Android pattern lock and shrunk it down to a smaller space on the screen. They also required the users to spin their finger in a circle after authenticating to wipe away any smudges that would have been left from authenticating with the pattern. Pre-touch is a capability of touchscreen devices that allows it to detect the position of your finger before you actually make contact with the screen. This video is from work by Hinckley and colleagues called Pre-touch Sensing for Mobile Interaction. They used a self-capacitance touchscreen to be able to detect the finger position roughly before you are actually touching the screen. In our work, our hope is to use this idea of pre-touch and bring it to authentication techniques. Now I'll introduce our 3D pattern authentication technique. The goals of our technique were first to use pre-touch information in the context of authentication, next to protect against shoulder surfing and smudge attacks as a good authentication technique, to avoid extra cognitive load or memorization, and also ideally to have minimal effect on time or error rate. This is a representation of our 3D pattern lock. The image on the left shows a 3D model representing what it looks like. Rather than the 3x3 conventional Android pattern lock, which is a grid of points, we extend this into 3 dimensions in space above the phone into a 3x3x3 cube of cylinders to connect. The image on the right represents what the user will see on the phone screen. Each layer of points in space is represented by a different color, and users can connect points between different layers to authenticate. This is what it looks like when the user is authenticating using the 3D pattern lock for 2 different patterns. There's a small colored cursor on the screen that follows the user's finger along. The color of this cursor represents the layer in which the user's finger currently is in, to be as useful as a guide for helping them authenticate. In terms of the actual number of possible patterns or pins that can be entered, for a 4-digit pin, there are 10,000 possible combinations. For a 4-digit conventional pattern, there's around 3,000 possible patterns. And for a 4-digit 3D pattern, there's around 400,000 possible patterns. However, if we limit this space to a practical space size, for example, in the case of patterns, by eliminating hard-to-reach trajectories, this reduces the space of 3D patterns down to around 20,000, which is still better than that of pin and pattern. Now I'll talk briefly about our implementation using motion capture. Since mobile phones currently don't have pre-touch, we simulated pre-touch capabilities by putting fiducial markers on a smartphone and on users' thumb when they're authenticating, and we instrumented a small room with Vicon motion capture cameras to track these markers. In the future, when smartphones have pre-touch built in, this setup would not be necessary, and all computation would be done on the phone itself to do part of the authentication. In terms of our implementation in more detail, we had 6 motion capture cameras that we connected to a network switch, which was in turn connected to a motion capture server, which computed all the coordinates in absolute position. These coordinates were sent over a network connection to a main computer, which was running a game engine. This game engine transformed these points into relative coordinates and forwarded this information over Wi-Fi to a smartphone, which then could render the cursor and the trajectories at the correct positions on the screen. Now I'll talk about the pilot experiment that we conducted, measuring the shoulder surfing resistance and performance of our technique. Our experiment compared our 3D pattern technique to the conventional pattern and pin locks. It was a within subjects design, and we recruited 6 participants. For each condition, or in other words, for each authentication technique, there were 2 blocks of 5 trials, and the first block was a practice round. The practice round was rendered with feedback, meaning that the turquoise lines that you see on the screen on the right, or the screens on the right, were made visible to the users, so they could see the trajectories as they were drawing them. In the non-practice round, these trajectories were hidden. At the end of authentication, participants would shoulder surf a video that we took of the previous participant authenticating. And this video was in without feedback mode, so participants could not see the trajectory. They had to guess what the pattern or pin was that the other user was trying to enter. Here are results for shoulder surfing resistance. We found with significance that pattern 3D was more shoulder surfing resistant than pin, measured in terms of the number of times it took to correctly guess the full pin or pattern. However, we did not find significant results for differences between pattern and pattern 3D. However, this cumulative distribution function shows that if we were to run the study with a larger sample size, this difference may become significant. Unfortunately, this increased shoulder surfing resistance comes at a cost. While authenticating using the pin and pattern technique can be done in usually less than 3 seconds, it takes around 8 seconds to authenticate with our technique. However, a large portion of the time authenticating with our technique is just homing in on the very first digit. Similarly, error rates are also significantly higher for our technique. The pin and pattern technique have an error rate of less than around 5%, whereas our technique's error rate is much higher. There are a couple of reasons we attribute to these differences in performance. The first are associated with issues with the equipment that we were using. The first is that we were only using 6 motion capture cameras, which resulted in a fair amount of jitter in the cursor positions. Using more motion capture cameras would work around this issue by having less jitter. There was also a small amount of network latency because the network engine used by the game library and also the Wi-Fi connection being used contributed to an amount of latency that was visible to the user in terms of the cursor position lagging behind their finger position. However, motion capture as a simulation for pre-touch is still got some advantages. For example, there's not very many things to affix to the phone or the user's fingers, so users can hold the phone with a realistic grip posture. Also, because motion capture is tracking your position over time, you can have precise location and also trajectory tracking, which could be useful for more sophisticated analyses. Further, there's a usability security trade-off always with these kinds of things. We have more layers and more precise hovering with our 3D technique, which leads to slower and more error-prone authentication, but it also eliminates smudge attacks and mitigates shoulder surfing attacks. Finally, I want to talk a bit about the on-screen representation of the 3D cube. We chose to use orthogonal projection, but perspective projection may be a good alternative. It may also be useful to dynamically rotate the cube based on the finger position above the screen to help 3D visual thinkers. We chose to use cursor colors as depth cues for what layer the user's finger was on. But there are other possibilities, for example, using shadows or indicating when a layer is changed as opposed to the absolute layer. This might actually help increase shoulder surfing resistance. It may also be useful to add dwell time to work around accidentally triggering and also tracking jitter from the equipment. In conclusion, we propose the idea of leveraging pre-touch for smartphone authentication. Our 3D pattern technique is completely immune to smudge attacks and is more shoulder surfing resistant than PIN. It's also potentially more shoulder surfing resistant than the conventional pattern lock. However, authentication times are longer with higher error rates, so future investigation is needed to see if this gap can be closed. Thank you for listening.